Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 10 mathematics, and in this video we want to have a look at simultaneous equations, and to be specific we want to have a look at elimination. So what we want to have a look at today is we've got equations where we've got two unknown variables, and then we get into the business of what simultaneous equations actually are. Lastly, we'll end off with the demonstration of how to use elimination to solve equations simultaneously. Without any further ado, let's get straight into the video. So, up to now, you've worked with equations that have only one variable, which is unknown. For instance, you will have something like 3 minus x is equals to 4, then you'll be asked to solve for x. Or you've got x squared minus 16 is equals to 0, you'll be asked to solve for x. Or something like 3 to the power y is equals to 243. Once again, in each of these equations, there's one unknown. We've only got x, we've got x, we've got y. Even in a scenario where we've got x squared minus 3x plus 4 equals to 0, there's still only one variable, which is x. Now, these are the nature of equations you've been working with to this point. There are cases in which your equations will have more than one unknown variable. So for instance, you could have something like 4 minus 6x is equals to 3y. Now you've got two unknown variables. There's x and there's y. In cases where you've got variables which are more than one unknown in an equation, you will need to use simultaneous equations to do so. Now, notice that we said here that we solve a system of equations. That's a plural, meaning that we've got more than one equation that has more than one unknown variable. I hope that this makes sense. If it does not make sense, stick around and we'll get to explain it. So, what are simultaneous equations? These are a system of equations. Once again, it's more than one equation that contain more than one unknown variable. What we should take note of is that these equations must contain the same variables. So for us to be able to solve equations simultaneously, first of all, we need to have more than one unknown variable in a system of equations. And these equations must have the variables which are exactly the same. For instance, if I've got 3 plus 6y is equals to 2x, I've got x and y as my unknowns. This second equation must contain an x and a y, meaning I could have something like 4y plus 12x is equals to 0, for instance. Once again, I've got x and y, so I must have the same variables in both equations. Also, these variables must have exactly the same exponents. So if this is y squared, this has to be y squared. If not, then we would not be able to solve such equations. Fortunately, however, in grade 10, you will only be dealing with linear equations. So what do we mean? Well, a linear equation, we said the highest exponent of the variable is 1. So when you look at the x, the exponent of x is 1, the exponent of y is 1. Exponent of x is 1, exponent of y is 1. So, there are two methods that you need to know that we use for solving equations simultaneously. We've got what we call elimination, and then we've got substitution. As we already mentioned, the subject of this video is to cover elimination. So, what we need to do when we are solving equations by elimination is we need to cancel out one variable. If I take an example that I was using earlier, 3 plus 4x is equals to, let's say, 6y. There's no ways I can solve for x here because of the y, which is also unknown. There's no way I could solve for y because of the x that is unknown. And this is why we need a system of equations. So if in my second equation I've got 12 minus 3x is equals to y, once again, even in my second equation, I cannot solve for x because I've got y as an unknown. I cannot solve for y because I've got x as an unknown. However, I could use both equations to choose a variable to cancel out. So if I, for instance, cancel out x in both variables, in both equations. So if this is gone, I've got 3 and 6y, I could solve for x. I've got 12, I could solve for y. I've got 12 and y, I could solve for y. Unfortunately, it's not just that simple to ignore the x or the y and then solve for the unknown variable. There's a process that we need to follow. As I've already explained, that we need both equations to cancel out one variable so that we remain with only one variable and constants. Once we have the value of this variable, we could use it to find the other variable that we canceled out. If this does not make sense, just stick around until we do the examples and then you'll get an idea of what we're talking about. So, how do we solve equations by elimination? First, we need to choose a variable to eliminate. It could be any of the two variables. What we need to do then is we need to make sure that the coefficients of the variable chosen, they have to be the same in each equation. So if the coefficient of x in my first equation is 1, the coefficient of x in my second equation must be 1. However, the one variable must have a positive coefficient and the second variable must have a negative coefficient. So if my y has a coefficient of 3, in the second equation my y must have a coefficient of -3. Now, this does not mean that your equations will come always having a variable with the same exponents with different signs. There might be a step where you need to manually go ahead and make sure that your your coefficients are the same. But we'll look at that a little later. Now, if we have the same coefficient in both equations, with one being positive and one negative, the variable can cancel out. We will then add the second variables in each equation and then add the constant. Then we can solve for the second variable. Then we substitute the value of the second variable into any equation in order to get the variable that we canceled out. Let's look at some examples so that we can really understand what's happening. So here we've got our first equation, our first set of equations. So we've got x minus 2y is equals to 5. Then we have minus 7 minus x is equals to y. Now, let's go to the writing pad and let's actually see how we could implement this. So what I like to do is, before I do anything, I need to make sure that my variables line up. So I want to make sure that I've got x in one column, y in one column, and then the constants in one column. Unfortunately, it's not the case here. So I'm going to choose one equation and I'm going to use the second one. What you also want to do is label your equations. Let's call this equation 1. Let's call this equation 2, or you could call it A and B. Really doesn't matter. I'm going to take equation 1 and write it as it is. So x minus 2y is equals to 5. On equation 2, what I want to do is I want to put my x first, then my y, and then the constant. And to do that, if I could do it on the side here, we've got minus 7 minus x is equals to y. I'm going to rewrite this by placing the x this side. Now notice that we did not take the x across the equal sign, so the coefficient of the x remains negative. It remains as is. Now I'm going to bring the y over. When bringing the y over, the y becomes negative. Last step is I'm going to take the 7 over. Since the 7 jumps the equal sign, the 7 becomes positive. So let's write that down. Now we've got minus x minus y is equals to positive 7. Let's quickly go back to our instructions so that we can see what we said we need to do. We said we need to make sure the coefficients of the variable chosen are the same in each equation. Let's quickly go back and check what we have. When we look at the x, the coefficient of x in my first equation is 1. Coefficient of x in the second equation is negative 1. They are the same, the only difference being the signs. So we can rightfully say that yes, we are done with the first step, that we had to make sure our coefficients are the same. So we are done with this step. We're going to eliminate the x in this case. Our coefficients are exactly the same. Now the next step says we need to cancel out the chosen variable. We have chosen to eliminate x. So how does this work? Well, check this. The x's have the same coefficient with the different signs. These two are going to cancel out. Now we look at this. We need to add this. Minus 2y minus y, that gives us minus 3y. Then I'm going to say 7 plus 5, that's going to give me 12. Now, if you look at this equation, I can actually solve for y here. So I'm going to solve for y by dividing by minus 3 both sides, so that the coefficients cancel out. I've got y is equals to minus 4. Right. Now, let's go back to our notes and see what's the next step. So, we've cancelled out the variable, we've added the second variable in the constants, and we've gotten the value of the second variable. In this case, we got y. Now we need to substitute the second variable, in our case, which is y, into any of the two equations. Let's check what we can do here. Now that we have y, we could choose to substitute y into any of the two equations. I'm going to choose to substitute y into equation 2 because it seems simpler seeing that equation 2 already has equals to y. I don't need to do any division or anything. So, minus 7 minus x is equals to y. Then minus 7 minus x is equals to minus 4. From here, I can simply just solve for x. So I'm going to take the minus 4 over, and I'm going to take the minus x over. So minus 7 plus 4 is equals to x. Minus 7 plus 4, that's going to give us minus 3, so the value of x is minus 3. So y is equals to minus 4, x is equals to 3. Now you might be thinking, what if I didn't substitute into equation 2? What if I substituted into equation 1? Well, your answer will be exactly the same. Let's just look at it for demonstrative purposes. So I could say, let me instead substitute y into equation 1. In equation 1, we have got x minus 2y is equals to 5. So let's substitute y is equals to 4. X minus 2 into minus 4 is equals to 5. So x and then minus 2 times minus 4, that's positive 8, is equals to 5. Let's take the positive 8 over. You get x is equals to 5 minus 8. X will be equals to 5 minus 8 is minus 3. There we are, we got exactly the same answer. Now, when you need to substitute, you do not substitute into both equations. I was just doing this to prove to you that any equation that you choose, your answer will be exactly the same. For your exam, you can only choose one equation. I hope that makes sense, and I hope that you guys are understanding the process behind elimination. Let's look at another example. So now we've got 3k minus 4 equals 2p, and k equals 4 plus 8p. Now let's come to the writing board and let's copy this down. Okay, let's see what we have here. So 3k minus 4 is equals to 2p, and then we've got k is equals to 4 plus 8p. This is equation 1. This is equation 2. Once again, I want to make sure that my variables line up. So I want to have k first, then p, and then my constant. So let me just get rid of that. I'm going to take my first equation, and I'm going to bring the 2p over to the other side. So that's going to become minus 2p is equals to, take minus 4 over to the other side, that becomes positive 4. Next, in my second equation, I'm going to have k here. Then what I'm going to do is take the 8p over to the other side. So then this is going to become minus 8p is equals to, let's see, the 4, we leave that where it is. Now, if you remember from the first example, already the x's had same coefficient with different variables, different signs. In this case, we do not have the k's having the same coefficients. We don't have the p's having the same coefficients. So what we first need to do is we need to choose a variable to eliminate. I'm going to choose to eliminate p. What I need to do is I need to make sure now that the p's have exactly the same coefficient with different signs in each equation. How am I going to do this? Well, there's a technique I can use. If I look at the p in the first equation, there's minus 2. The p in the second equation has minus 8. This guy, remember, I want it to be positive 8p so that it can cancel out the second equation. What can I do to the first equation so that the minus 2 becomes a positive 8? Well, what I can do is I can multiply the first equation by a positive 4, a negative 4. I need to multiply the entire equation just so that the p can be affected. So let's see what this is going to produce. Minus 4 times 3, that's going to give us minus 12k. Minus 4 times minus 2p, that's going to give us positive 8p. This is equals to minus 4 times 4, that's going to give us 16. We did not touch the second equation, so that remains as it is. K minus 8p, this is equals to 4. When we have something like this, what you will notice is that the 8p's will cancel out. So positive 8p minus 8p, that cancels out. I need to add this. Minus 12k plus k, that's going to be minus 11k, is equals to 16 plus 4. Let's see. Whoops, I made a little bit of a mistake. This should be minus 16 because we multiplied minus 4 by 4. So minus 16 plus 4, that is going to give us minus 12. Now what we could do is we could divide both sides by minus 11, divide by minus 11. This is going to cancel that. Excuse my terrible handwriting. K will be equals to positive 12 over 11. Brilliant. Now that we have found the value of k, what we could do is we could substitute it into any of the two equations. So I'm going to choose to substitute the value of k into equation 2. So substitute k into equation 2. Now in equation 2, we had k is equals to 4 plus 8p. Now what we want to do is we want to solve for p. So 12 over 11 is equals to 4 plus 8p. I want to transpose the 4. So 12 over 11 minus 4, that's going to give us 8p. Let's see. 12 over 11 minus 4, so that would give me something like 12 over 11 minus 44 over 11. And that's 8p. And so from here, we could just say 12 minus 44, that's going to give us negative, let's see, 32 over 11 is equals to p. 8p, sorry. Divide this by 8. Divide this by 8. This is going to cancel that. This is p. Negative 32 over 11 divided by 8, that is going to give us, let's see, 8 goes into 32 4 times. So that's going to be minus 4 over 11 is the value of p. We have the value of k. We have the value of p. There we are. We're done solving this equation. Brilliant. Life is great. Let's look at the last example that we have. So this is an interesting one. 2m minus 3n equals 6. 3m plus 2n equals 4. Let's copy this down. So open up a new sheet of paper and let's copy down this question. So we've got 2m minus 3n is equals to 6. Then 3m plus 2n is equals to 4. So let's label this equation 1. Let's label this equation 2. The first step we said is we need to choose a variable to eliminate. Okay, let's say I choose to eliminate m. Now, let's check. Do our coefficients have the same sign? Well, they're both positive. We're supposed to have different signs, so no. Are the coefficients the same? No. Now we need to check. How can we make these coefficients the same? If you remember from the previous question, if we look at equation 1 and we consider this 2m, we could say to ourselves, what can I multiply with 2m so that I get 3? And if you think about it, there is no whole number that you can do that to. You would have to multiply it by some type of a fraction. Or even if you ask yourself, what can I do to 3m so that I get it in the form of 2m? Once again, that's not possible if you're using just a whole number. You need a fraction. To solve this problem, what I'm going to do is, for my first equation, this is 3m, so I multiply my first equation with negative 3. For my second equation, what I will do is I will multiply my second equation by, this is positive 2, I will leave this and multiply it as positive 2. You'll see why in just a second. So, minus 3 times 2m, that's going to give us minus 6m. Minus 3 times minus 3, that's going to give us positive 9n. Negative 3 times 6, that's going to give us minus 18. For the second equation, 2 times 3m, that's positive 6m. 2 times 2, that's going to be positive 4n. And then 2 times 4, that is going to give us 8. Now, why did I multiply with a negative number on the first equation, but multiply with a positive number on the second equation? Because now, remember, if you look at the m, our coefficients are the same, it's 6. The signs are different because the first one is positive and the second one is negative. Sorry, first one is negative, second one is positive. These two can cancel out. I can now go ahead and say 9 plus 4, that's going to give me 13n. Negative 18 plus 8, that's minus 10. I can then divide this by 13 and divide this by 13. This will cancel this. N will be equals to minus 10 over 13. Brilliant. Now what we can do is, let's substitute n into any of the two equations. I'm going to choose equation 1. So, we've got 2m minus 3n is equals to 6. Let's substitute n. So 2m minus 3 into negative 10 over 13. That's going to give me 6. So 2m, negative times negative, that gives us positive. 3 times negative 10 over 13, that's going to give us positive 30 over 13 is equals to 6. Now we can solve for m. So 2m is equals to 6 minus 30 over 13. Now, the simple task that you would just have to do is to type into your calculator what is 6 minus 30 over 13. And that will give us 48 over 13. So 2m is equals to 48 over 13. Now, we haven't yet solved for m. What we need to do is we need to divide this by 2 and divide this by 2. This will cancel this. Now the m will be equals to 24 over 13. Please take note that we have to divide this entire fraction by 2, not just the denominator. Awesome. Now that we have the value of m, we could substitute into any of the two equations to get the value of n. What I'm going to do is I'm going to substitute it into equation 2. So, substitute m into equation 2. Now, in equation 2, let's just copy this down. We've got 3m plus 2n is equals to, let's see, what was that? 4. Let's substitute m. This is 3 into 24 over 13 plus 2n is equals to 4. Now, 3 times 24 over 13, let's see, 3 times 24, that would give me 72. So, this is 72 over 13 plus 2n is equals to 4. Let's solve for n. 2n is equals to 4 minus 72 over 13. 2n would be equals to, if we say 4 minus 72 over 13, let's see, that would give us negative 20 over 13. Divide this by 2, and divide this by 2. The value of n turns out to be negative 10 over 13. We have the value of m, we have the value of n, we are done. Life is great. I hope that you guys enjoyed this video and that you found it productive. I hope that you've learned something about simultaneous equations in grade 10. If you do enjoy the video, if you have learned something, please give us a like, give us a thumbs up. Please subscribe to the channel so that you can continue receiving more content like this. And if you really enjoy and love the content, please share it with others so that everybody could be benefiting from the knowledge that you're receiving here. Until next time, bye-bye.